Okay, all right. So thank you guys for joining. I welcome you to this training. It's going to be a life transforming training for you. It's going to be a new skill set acquisition training for you. You know that no price can be paid to acquire knowledge. Knowledge is sought out after. So knowledge is, especially this type of technical skill, is quite not here. STATA as a software is currently $220 for LMICs, countries like Nigeria, countries that low and middle income countries. So it's not, I don't know how many of us that can afford that. So that is why I had to get the cracked version for this, but for the purpose of this training, so that even after the class, you will still be able to still use it perpetually. So, but please know that STATA is a, a software that is bought in dollars. You are meant to buy your own personal license after the training. So, but I know that many people may not be able to afford it. So I had to fetch that copy and give to you guys. So ordinarily for trainings like this, we usually add the cost of the software so that when the participant pays, we'll be able to get the license version. So this is our curriculum for this training. The installation, we are going to take is the introduction to STATA now. Then the retesting will come after. Testing will come after the class. We're going to do a post testing and then some assignments in between the training. So we are going to look at this either today or tomorrow, lecture 1. We are going to look at the introduction to STATA software interface. So many of us have heard about this, that there are so many data analysis softwares that are available. We have R, we have Python, we have SPSS, we have STATA, we have a wide range of them. But the reason why STATA is very unique because it does not require you to know a lot of programming language. It's not high-level programming language, even though it uses command line, but it's not high-level programming language. So it does not require you to start coding, so it does not. The language of STATA is very, very simple and is written in plain English. And then STATA has the ability to analyze millions and millions of data, depending on the version, on the edition that you license, that you bought. We have the PE, we have the SE, we have the IC. So these are different versions of STATA. And then STATA has become very, very, very good. STATA is very fast. Unlike SPSS that is quite slow in processing data. So we are going to look at the command line of STATA. We are going to look at the modes. What does it mean to have a do file, a log file, and a DTA file? We're also going to look at the point and click technique for descriptive analysis. We're going to look at the mean, median, and range, the confidence intervals. How do you generate this? How do you plot your graph in STATA? How do you do box plots? How do you do histogram, scatter plots, bar graphs, and the rest? So we're also going to see how to do data cleaning, some data manipulation, how to use a log file, how to code, how to recode, how to generate new variables, then how to use STATA as a calculator. Then if you want to do data entry inside of it, you can also do that. We're going to look at some analysis that we usually do in both research, in data analysis, everywhere. I'm going to look at chi-square tests, relation analysis, going to look at t-tests, scatter plots, going to look at the 2 types of t-tests that we usually do in research. When do we use t-tests and how do we interpret the results? Many people know how to Many people know how to use the tool, but they don't know how to interpret the results. So that becomes an issue. Some persons will also not know how to. Some persons will also not know how to when to use the tool for the analysis. So these are things we are going to deal in the course of this training. And I'm going to take it very, very slowly. I'm going to take it from the down, from the scratch. I assume that you guys are not good in it. I assume that you guys are, so no matter your level of proficiency, please, we are here with us. We are going to take it bit by bit. So we are also going to look at one-way ANOVA. We are going to look at one-way ANOVA. When do we use it? And what do we use it for? Then post-hoc analysis too. What is post-hoc? When do we apply? We are going to look at non-parametric analysis that we usually do. The 4 non-parametric analysis that we usually do. Then how do we analyze our data that is not parametric in STATA, and how do we interpret the results? We are going to look at by next 2 weeks. We are going to look at modeling, introduction to regression modeling, odds ratio, relative risk for cohort studies, odds ratio for case control studies, logistic regression, how do you interpret it, coefficients, and the rest. Then we are going to also do linear regression modeling and some of this other regression modeling. So this is, and we are going to also, by the 7th and the 8th day, we are going to dedicate 2 days to Microsoft Excel to look at how do you enter data entry in Excel. In case you go out and you collect data from your study, how do you do the entry? How do you analyze? How do you also visualize in Excel? Because many of us use Excel as our primary data collection tool. So I'm glad to be your tutor for this training. I'm a research fellow working for IHVN in Nigeria, leading some cancer research here. I'm also a PhD, second-year PhD student, epidemiology and biostatistics. So welcome, I welcome you to this skill acquisition training. I hope that it's going to be a smooth ride for all of us. Please, I want to encourage everyone. Today's class is an introductory class, so I allowed everybody to join. I welcome those of us that are joining now. I want to appeal to everyone, please, this training is a paid training. It's not free. I made it in such a way that it can be as low as the fee so that people can afford it. As I said before, STATA is quite an expensive software. But I made sure I got the cracked version for all of us. I didn't charge us for that. I only charged this, what you are paying is just for the training and the course material. So please endeavor to do the fee. If you can't pay the 100% at once, no problem. Do 75% or 70% and then pay off before the end of the training. I also want to tell you that you are going to be awarded certificates. You are going to be given a project at the end of this training to do. But when you are done with your project, you have your certificate of training. So the whole of this month, this June, we'll be looking at STATA and Microsoft Excel. So I welcome everyone once again and welcome to class. So let's start to look at the software proper. As I told us before, there are so many data analysis software that one can use, one can learn. Many of us may be proficient in SPSS, R, in EPinfo, probably Python, if you are good with programming. So let's look at STATA. STATA is used in the field of social sciences, economics, medical sciences, all types of data. In short, STATA is all in all. The version of STATA that they released in this year, version 18, has so many data science applications, neural networks. It has nearest neighbor algorithm, decision tree. For some of us that are into data science, you understand what I'm saying. So STATA is not just used for data analytics, it's also used in data science, it's used in research. So as I said before, it's a licensed software. It's not free. It's not like R that is free. The recent version is version 18. But when you use it, you will really, really love it. And honestly, by the time we start hands-on, maybe today or tomorrow, you will really, really fall in love with it. It's very easy and to use, I assure you. So it has the IC version, it has the MP version, and it has the XE version. The version we are going to use for this training is the IC version. The one I sent to you is IC, the standard version. So this one, they have different prices for them. That this ones can take, this SE version can take millions and millions of databases at the same time. So these are the versions. Then when you compare STATA to other softwares, as I said, SPSS, SAS, STATA, R, Python, you will see the advantages that STATA has over others. But the learning curve is gradual. You see the learning curve of R and Python, that's steep. It has both programming and point and click. So if you are not good with programming, this is a software for you. Because R and Python demands that you learn both the statistics, the theory, and the programming. So you'll be juggling it at the same time. What we call point and click is what we call GUI, General User Interface, where you can just click and do your analysis without knowing the codes. For data manipulation, I assure you it is very strong with data manipulation. For data analysis, STATA will do a lot of, make your work easy. For graphics, well, the graphics is not, for me, I love aesthetic graphs. It's not so wonderful, but it's okay. The graphs are nice. It's far better than SPSS graphs. Then the costs. R is open source, Python is open source, but STATA is bought. It was released in 1985, so it's as old as this. So let's look at the STATA interface. This is what we call the STATA interface. So whenever you open your software, this is the first thing that you see. Whenever you open your software, this is the first thing that you see. Please don't get confused. STATA has 5 interfaces. This interface called the review box, I choose to call it the history box or the command history box. This, okay, let's go like this. This is the history box or the review box where your commands are stored. So for each time you put your command here, it will come here and stop. I hope you understand. You guys understand what I'm saying? For each time you put your command here, STATA stores it for you here. So you can reuse each of the command that you always use. You have it here. So this is the command box where you input your command, you type in your command, and then you get your output here or your result. Then the command is saved here, like a history. Then this is where you see your data sets. The data that you're analyzing, your variables, this is where you see them. We call it the variable list. Then this is where you have the variable properties, or you can wrangle or manipulate your data. This is it. So you have the review box, the first quadrant. Well, it's not like R has 4 quadrants, but STATA has 1, 2, 3, 4, 5. The results box, the review box, or the history box, command box, where you input your command, where you see your result, your output, your variable, the properties of your variable here. Okay. Now, there are some important toolbars. If you look at this place, you see these toolbars here. There are some important toolbars that you need to know. They will help you a lot. There are the most important ones that I'll highlight. So that is what we call the log file. See it here, it's like a notebook. This is the log file of Stata. The log file is where you write all your commands and your outputs. There is a way that Stata is built, just like R. In R, you can't save your output and you save it as a script. In Stata, you save your output as a log file, such that it can open with a notepad. So that's why it's like a notebook where you write, as you write your commands, do your analysis, it saves here. Now, there is what we call the do file editor, or just the do file. The do file is where you write your commands only. The do file is where you write and execute your commands only. The log file has both command and result, but the do file has only your commands. So let's take, for example, you have a data set that you finished your analysis, and someone in the UK or someone in another country wants you to please share with him the command that you used for your analysis. So what you need to do is just to send him the person your do file. The person will open it using his own Stata software, be able to access all the commands that you used. Now, these two windows are what we call the data editor and the data browser. I'm going, when we get to the practical, you're going to see the difference. There are sometimes you will want to see your data when you are doing analysis, the way it appears in Excel, in rows and in columns. So you either use the editor window or the browse window. The editor window allows you to just to see and edit, while the browser window allows you to just browse alone without editing. So don't worry about this. We are going to, when we do the practical, you catch the difference. There is also a help tab here that you can always use to help. So let me assume that you forgot the command for chi-square. You just type help chi-square. Stata will pull up the command for you. It's as easy as that. Okay. So in our practical class after this course, we are going to, after this presentation, we are going to see how do we set a default directory, how do we open a file, how do you open a data file, how do you convert your data from Excel to Stata, how do you import, how do you open a log, how do you save your data set, and how do you use do files. So this is a practical demonstration. Okay, these are the steps to creating a log file in case you forget. This is how we create a log file in case you forget. We are going to practicalize it, see how it is done. I believe that once you do it once, you will know how it is done. Okay. Then, how do you create a do file? This is how you do that. All right, sorry for the interruption. Okay, so this is how you create a do file. I told us that a do file is a file that contains your commands, where you store your command, and you can share with somebody else. So this is a do file is a list of commands that you wish to perform on your data. So instead of saving changes in data sets, you run the do file on the original data. I'm going to show us how this is done. It's a very simple process. Then you can get help. As I said, you can always get help in case you need help in your software, navigating your software. These are the logical operators we use for data manipulation. Maybe you want to use your Stata as a calculator, or for any data manipulation you are going to do. These are the logical operators. Of course, this is general to all softwares, whether R, Python, SQL, whatever data software that you are using, a language that uses command line. These logical operators are the same everywhere. These are the simple commands that we use to manipulate our data: the browse, the sum, the inspect, the describe, the list. There's another one called the codebook. We are going to look at all of them. So in case you want to generate variables, new variables, this is the command. This, we are not going to do this today. We're going to do it either tomorrow or Saturday next week, when we start generating. We are going to follow strictly our curriculum when we start generating new variables. Somebody sends the data to you, something like age, and tells you to categorize it into different age ranges, or something like BMI, or something like income, and then tells you to categorize it into different categories. You are going to generate new variables. So this is how, one of the ways we do that. This is the command for ANOVA. This is the command for chi-square and the rest. We are still going. So this is a general overview. Labeling a variable, types of variables. I hope we all know. Okay, let me not assume that we know. I'll need to talk on this a bit. Please, before you start data analysis on any software, whether STATA, whether SPSS, whether, you need to understand the difference between data and variable and the types of variable that we have. Please, this is important. This is important. So does anybody know the difference between variable and data? Can anybody try? What's the difference between data and variable? Are they the same? Yes, anybody? You can unmute and speak, please. Hello, anyone? I hope you guys can hear me clearly.
Yes, I can hear you.
So try.
Okay, I would say the data is the actual information you're working with, while the variable is more or less like having different groups of data. For example, age could be a variable, or gender, and then the different ages, 5, 6, 7, would now be the data you're working with.
Exactly.
I don't know if I'm right.
Exactly. Thank you. Thank you. You are correct. So the data is the actual facts, the actual information that you are collecting, while the variable is the name or the attributes given to the data. So you're asking people their age, you are collecting data on temperature, you're collecting data on whatever it is, laboratory data, clinical data, whatever it is. The actual recording fact that you're getting from the person or from the group of elements or people is the data, while the name of that thing you are collecting is the variable. Okay, so we have basically two types of variables. We have the quantitative and the qualitative type of variable. Can also call it continuous and categorical. Continuous and categorical. What does it mean for a variable to be continuous? A variable is said to be continuous or quantitative when it contains numerics, that's numbers. Let me take, for example, age, something you can quantify in numbers, call them quantitative variables. So you need to know the type of variable that your data is before you start analysis. Inside the numbers, there is another one we call discrete. Discrete variables are variables that take up just whole numbers. Something like age. Age cannot be said to contain decimal points or fraction. If I ask you your age, you won't say you are 25 years point 2 months or 25 2 months. No. You can either say age at last birthday. You can either say you are 30, you are 50, you are okay. Then categorical variables are also called qualitative variables, variables that are made up of alphabets or text or strings. We call them strings. Any variable that is made up with words is called strings or text. For example, if I ask you your gender, can I say you are a male or you're a female? Because they are made up of strings, they can now be categorized. That's why I call them categorical variables. You can either be a male or a female. You can either be a doctor. If I ask you what's your occupation, you can either be a doctor or a farmer or a nurse or an engineer or whatever. So you cannot quantify it numerically. That's why we call it qualitative or categorical variable. Now, categorical variables are divided into two. I have a slide on this, please. I have a slide on this, but maybe I'm going to share it tomorrow. I already sent it to you guys. It's among the course materials where we defined this thing very clearly. Categorical variables can be divided into nominal and ordinal. Nominal and ordinal variable. You may have had this in your statistics class or wherever. But please note the difference. What is the difference between a nominal data and an ordinal data? A nominal data does not contain any category or any order. Let me not say category, any order of arrangement, any level of measurement. Let me take, for example, sex. If I ask you what's your sex, you are either a female or male. Female and the male are equal. Thus, there is no order, there is no ranking, there is no level of classification, no. But if it is ordinal variable, an ordinal variable is a variable that contains order or ranking or strata. Example, there is what we call Likert scale. When I ask you, what do you feel about this lecture? You say, well, it's good, it's very good, it's poor, it's very poor, it's excellent. So you see, I started grading, I started ranking your response. So that is what we can call an ordinal variable. So good, very good, excellent, poor, very poor. Strongly agree, disagree, strongly disagree, agree, undecided. These are categorical variables, but they have order. They have an order of arrangement. So we call them ordinal variables. So in STATA uses 3 color codes. Please note this. We are going to still do this practically. STATA uses 3 color codes to differentiate between these variables that I mentioned. It uses a black color for numerical variable, it uses the red color for string variable, and it uses the blue color for encoded variables. I will explain to us what it means to encode when we get to that stage. So STATA, when you see your data in STATA, it can either be 3 colors, black, red, or blue. Okay? All right. So we are going to see how the graphs we use for continuous variable, categorical variable, then scatter plot. What is a scatter plot? When do you use it? How do you plot it in STATA? The line of best fit. The histogram. What's the histogram used for? How do you plot it in STATA? And how do you do your bar chart? So all these are contained in our course curriculum. So thank you for listening. And thank you. Do you have any questions at this point before we get to the practical? Does anyone have any question? Do we all understand? Are we good to go?
Yes, I understand so far.
We're good to go, sir.
Okay. It's clear so far. Oh, thank God. All right, so let's get to some important concepts that we need to know. All right. So I said this is your STATA software. So when you come to your software, this I said you have 5 interfaces. Number 1, the command interface. I can pull this up. The output interface, the variable interface, and the properties interface. Now, these are the citations for STATA in case you want to cite it in your work, in your study, your research. This is a version that we are using, version 15. This is the license serial number and the person this is licensed to. Unfortunately, this is a cracked version. That's why you are seeing this. So I have my own personal, let me show you my versions. 17, my own personal license version. Okay. This is version 17. So you see, it has been upgraded to statistics and data science. The other one is statistics and data analytics. Now, version 17, 18 on this, they have done a lot of, and this is the version that I'm using, STATA BE. So this is my license number and this is my name. This is my university where it is licensed to. So when you buy your own license after this training, you have your own serial number, your name, and so it will always be here. The reason why you should do this is because that you may submit your work in a journal. I've had instances where we submitted very big studies, cohort studies, follow-up longitudinal studies, clinical trials, and then we said we use data for analysis. They may tell you to send your license number, serial number, to make sure that you use the license version. Well, it's not all the time, but it's possible. So please, after this training, if you have the money, get your own license version. I think I have some license I bought last year, and it may be cheaper for you, Sha, if you want this version. I assure you there is a whole lot this version does. There is a whole lot of improvement here that is not in version 15, even though the command line are the same thing, everything. But it's not, when you start analyzing, you start seeing the difference. So I think I have some licenses. If you need them, you can contact me after the class. I think let me be sure, let me check and be sure that I still have some licenses that are still remaining. Okay, so back to version 15. Please, just a minute. Okay. All right. Someone is asking for the link to the meeting. We are supposed to be more than this in this class. Okay. So let's see. This is our software. Let's do some data introduction now. So when you come to the software, you either choose to enter your data here by using the browse window. See what I just did? Now, when you want to navigate the spreadsheet part of STATA, you use 2 commands. It's either you use the browse command. So see how I impute my command here, and then I press enter. You don't need to press any control, anything. Just put your command, press enter. Stata will take you to the rows and columns of that appears like Excel. But unfortunately, because I'm using the browse command, I cannot impute anything here. So there is another one called the edit. The edit command, EDIT. So with the edit command, you can actually type something, H. You can type, you can come here for this. You can come here and define your variable and say age underscore of. Remember that variable names does not take up, it does not take up, what do we call it? Special character. Space is a special character, please. Regardless of any software you're using. Stata, arrow, SPSS, age of participants. So see, I've named my variable. I can say this person is, so I can come here to sex. Okay. So, okay. This is sex distribution, or let's say gender distribution. So in case you want to, you choose to do data entry inside here, no problem, you can go ahead. But personally, I don't do that. I don't also advocate people do that because there are, if you make some mistakes, it's not, Stata is not as powerful as Excel in data cleaning. So I usually tell people, I recommend you enter your data in Excel. Mohammed, the meeting is already being recorded. Hello, Mohammed.
No, not yet. Thank you.
Okay. I'm going to allow you. You want to record at your end? Okay. So I prefer people to enter their data in Excel and then import it into this place. So I just showed you how you can do that. So as whatever you do in Stata, there is a command that it generates for it. There is a command that it generates for it. So whatever you do, you generate your command and the command stores here such that you can reuse them again. Okay. Now, I sent you guys a data in Excel for this training, healthy lifestyle data set. So that is the data we are going to work with for the course of your learning. So I sent you guys this data set. Then I sent you a PDF file. I sent you a PDF file. So please, I believe everyone should have it by now. This is the data set I sent to everybody. This data set we're going to use for our learning. So this data has been cleaned and has been properly entered into Excel. But we are going to use Stata to analyze it. Remember that when you talk of entering data in Excel, Excel has two data formats. We may not know, so let me bring this in. Excel has two data formats. Excel can either store data as XLS or as CSV. Either as XLS or as CSV. When you store data like this in rows and columns, is to store as XLS. But when you download data from a database, that's a secondary data. This is called a primary data because you computed it yourself, or the source of collection was from you. But when you download data from a database, it becomes a secondary data. So such data that comes from databases, I have this database here, this popular database. Let me show us. Called, many of us may know it if you're into clinical research, called the red cap. Okay. There are plenty of others. So this is a database. REDCap means Research Electronic Data Capture System. Research Electronic Data Capture System. So this is my administrative password. So I'll log in into this database and then look at studies that we've done. This is a study that we are doing now, COVID-19 study. So this is the database. These are the patient information and a whole lot of things. So if, example, that I want to export data from this database into Excel, if I want to see export data here, it will export as CSV. This export data, it will export as CSV. CSV means comma separated values. The reason why it's exporting as CSV is because many times the data from databases are usually very heavy or very large. So Excel will condense it to a comma limited edition, a comma version, such that instead of having columns and rows, you will have comma, 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 comma. So that is the CSV data file for you. So if you want to do your data importing into Excel, into STATA, sorry, you need to know whether your data is in XLS or a CSV. So, but most of the data you are going to work with in normal clinical setting, search setting, is usually data you collect and you input. Even if it's in CSV, you can quickly convert it back to XLS. So how do you import data into STATA? You click on this file here. Please follow me. Follow me. If you have any question, ask me immediately. You can unmute and ask. Click on this file here. Click on import. Can you see it? Then you click on Excel spreadsheet. Now look at the file extension. You see it does XLS. So this is the data that I want to. This one is for CSV. That is still Excel, but this is CSV. This is XLS. So click on Excel spreadsheet. When you do that, you have a window like this. You click on browse. You click on browse. And then you go to where store your data set. This is where store that this is the data set you are going to use for this training. So once you click on it, say open. Are you following me? Now, at this point, remember that Excel stores data in sheets. Sheet 1, sheet 2, sheet 3. While SQL stores data in tables. But we are not, this is not a database class. So you need to know the data you are importing, which sheet is it in? Is it in sheet 1? Is it in sheet 2? Is it in sheet 3? So of course the data we are exporting has just one sheet. So that's why we are only seeing sheet 1 here. And then there are two things here. Import first row as variable name. Please always tick this. Always check in this whenever you are doing data importing into STATA. Please don't forget. If you don't tick it in, STATA will take every data here as strings. So this age, sex, that is your variable, it will not see it as variable, to see it as data, which unfortunately, that's not what you want. So, but when you click on this, import first row as variable name. So this first row will now be variable name. So you say okay. You say okay. So how do you know that you've imported your data set? Come to your variable window. You see that it's no longer vacant. It has your variables here, your age, your sex, your location, baseline weight, the height, group, health literacy, smoking status, asthma diagnosis, diabetes, weight after intervention, health literacy after intervention. So these are all the variables, serial number, age, these are all the variables that we have. This is the name of the variable, this is the level of the variable. And when you click on each variable, you see the variable properties. Okay? So from here, you can start analyzing them one after the other. So this is the beauty of STATA. This is the beauty of STATA. Now, remember I said when I was in introduction, that there are 3 color codes. If you were not here when I was in my introduction, please note that there are 3 color codes. Whenever you have data in STATA, there are 3 color codes: the red, the black, and the blue. Say that the red. So let me show us. We have data now in our memory. So we use the browse command, BROWS. Or if you don't have the energy to type it in full, you can just say BR. Just like this. Say enter. Now, what can we see here? What colors can we see here?
Black and red.
Black and red, very good. So what does this signify? Who can tell me? Why are some data in black, some are in red? Quickly.
Black is numerical. Red is like in words or strings.
Categorical.
Somebody say words or string. Is that what we call it? We call it categorical variable.
Categorical variable.
Exactly. So whenever you see this color, note that STATA is seeing that variable as what? Categorical variable. Now, please let me warn you. There are sometimes people who want to enter data, maybe in Excel or anywhere in SPSS or whatever, and they will come here and please, you are not allowed to enter data as alphanumeric. What do I mean? Somebody wants to enter age. He's saying 40 years. He's typing 40 and putting years, 21 years, 39 years. When you import that data inside STATA, instead of STATA to be seeing it as age that is numerical, it will see it as string, unfortunately. Or if you come here and you are saying maybe height, you are saying 1.57 meter, 1.67 meter. No. You can indicate the unit of the variable at the variable. You can say age, bracket, years. You can't come here and be saying 40 years. No. There are also sometimes, because of how Excel formats data, there are some times when I was, those days that I started learning STATA newly, I will be surprised that STATA will be seeing my age or my numeric variable as string. I will not be wondering, what's happening? I will look through, I will not see any text, but it still be seeing it that way. So when I now go back to Excel, I found that Excel formatted it as text. So what we do in STATA is to use a special command that we call dstring. In case you come across that scenario after this training, dstring, you put the variable name and then generate a new variable. Do you understand what I'm saying? We have not gotten here yet, but it's a possibility. Call it the string. You put the variable you want to the string. This one will not work because it's already not a string variable. Then you generate H2. Okay? Now, I was telling us the difference between browse command. In browse window, I cannot, you see, I cannot edit anything from here because I'm in the browse window. See it here, data edit or browse. But when I use the edit ed command, I can be able to edit something. See, I can say 57.5. So that is the difference between the browse window.
Last one I swap for this.
You said?
That you are not going.
Are you talking to me? Hello, is that a question? Oh, sorry. I think she was on call or something.
She's talking to someone else.
Yes. So that is the difference between welcome everyone that is joining now. Welcome. Please always join this class early. This is a 2 hours class. I don't want us to extend it so that we can start on time and finish, please. And whatever step you miss. Okay.
I was talking at 8 o'clock, sorry.
This class is being recorded, so you can go over the class before tomorrow's class. I'll send us the record. Okay, so I was talking about the difference between browse and edit. Now there is another color. Remember we said red, black, another color called blue color. But you will not see it because we have not encoded any of these variables yet. So you are not going to see it for now till we start encoding. All right. So let me stop here. I don't want us to start analysis yet. Let me follow our curriculum. Don't worry. So I've showed you, I've done introduction to STATA software interface. So let's use this remaining 1 hour to do this lecture, introduction to basic statistical concept. And then tomorrow we'll now start all this analysis. We'll start our descriptive analysis, our graph plotting, our normal distribution, a lot of things. All right. I hope you are enjoying the class. If you have any question, you can ask me. This is a training that you paid for, please. You can ask me a question at any point. Okay.
Please, I have a question. The licensing, what's the cost of the licensing? You said you were going to check if you actually have license or something. So
my April students, the 3 of them that are well, we bought it as a group. We bought it as a group. So I have forgotten what I actually paid. Well, we split. There is a way to buy STATA as a group. We bought it 6, so 3 persons used it. I think it's still remaining either 1 or 2. It should be around 50 or 60,000. It's a perpetual license. You wouldn't have to pay again. You pay perpetual. It will be with you, except you lose your laptop. So instead of going to buy a personal license for $220, so you can opt for that option. So
Can it be
just,
used only on one laptop? Can it be used on another laptop as well? If you want to move from one laptop to the other.
well, if you want to move from one laptop to the other, why are you moving? Is it simultaneously? One license cannot work simultaneously on one license. It can be on here and be on there. Because it's one
Okay,
license
thank
that you
you.
bought. Do you understand? So if you have a change, if you want changing laptop, no problem. The license key will be with you now. You can always install on your new laptop.
Okay, thank you.
All right. So I welcome you guys again to this lecture. Very soon, we have up to 23 slides. I'm going to take it slowly. By the time we finish this lecture, you are going to have an overview of everything we are going to do in this course. An overview. So this is the aim of the course. At the end of the day, you should be able to apply, at the end of this training, you should be able to apply basic statistical tools using STATA to conduct analysis. And then, let me tell you the truth, one of the things that used to rubbish funded studies, a lot of research is inability to analyze data properly. I've been in this field I've started analyzing data in 2013. So this is my 9 to 10 years. I've had I published quite a lot of papers, so I have a lot of experience. Many papers that I rejected are usually either because of bad statistics, not knowing how to present results, you didn't use the right test, you deviated from your specific objectives, you didn't do the right analysis, you used so a whole lot of things. So you see people, they will pay a lot of money in getting data, sponsoring studies, making sure they follow procedure, but they won't invest the money, such amount in analysis. Because if you get your analysis right, you will get your results and your findings right. So that's why I usually make out time to do this training every month or weekend so that I can at least do my part in mentoring people. By the end of this training, you should be able to analyze your data, at least, even if it's not at advanced level, because this is a basic training. There are still so many advanced things, but at least being able to do your own research and improve your research visibility. Okay? Sorry, this is an 8 weeks course, not 3 weeks. It's designed to be, okay, sorry, a 4 weeks course. 2 days in a 8 days, 4 weeks, yeah. It's designed to be interactive and hands-on. Please, you must attend 80%. You must attend 80%. Feel free to stop and ask me questions. I assume that all of you here have very low knowledge, or you don't even know at all. But even if you have some knowledge, no problem. We're still going to come to your level. So I said conclusions from research are majorly dependent on the conclusions that you derive from your analysis. Very expensive research endeavors have been flawed by poor analysis and design. Please, when you are doing studies, especially big studies, involve a biostatistician, involve someone that is expert in this. Don't assume that you know what to, so that you don't, especially at the level of study design, at the level of, before you even start collecting data, or before you start validating your data tools, please involve somebody that will look at your tool, look at your objective, make sure that whatever you want to do is doable, both on the field and the analysis is properly, your data analysis plan is pointing to your objective. So the good knowledge of statistical analysis will assist you in design of high quality studies with measurable objectives. Remember that when you design your studies, your objectives are meant to be SMART. S-M-A-R-T. Specific, measurable, achievable, time-bound, and what? Reliable and time-bound. That's math. So the measurable part, the M part, is this part. The objectives must be measurable. I said your specific objective must be SMART. Specific, measurable, achievable, what was that R? I think it's reliable or something. And time bound, yeah.
Reliable.
Irreliable, yes. Journal publications are getting competitive, and major reasons for high article rejection is usually. Well, yesterday I had a very bad experience. Someone sent me a journal, an article they want to publish, up to 3 articles there. So I took my time to review it. Oh my God, come and see, Paul, I called the person, I said, who did this? And how did this article get to this stage? Did this undergo proper? The objectives were different from the results. So the person that analyzed the work did not know what exactly to do, the test to use. The person that the work was analyzed for did not understand the analysis, just went on to do discussion. Even the people that reviewed it for publication did not. So I didn't know where to start from. Of course, you know that abstracts for conferences, awards, proposals are very competitive. So it is in your best interest to know how to present your tables and do your analysis properly. All right, so we've done this basic concept of data analysis. We said there are 2 types of variables. We have the categorical, and then we have the continuous. So under the categorical, I told us we have either nominal or an ordinal. A nominal variable is a variable that is categorized without any rank. Example, gender. So if I ask you what's your gender now, so you're either a male or you're a female. There is no ranking. But for ordinal variables, if I ask you how happy are you, or what's your level, or if I ask you how good, okay, rate this facilitator, or rate this class, or rate this training. You can either say it is good, very good, or poor. You can either say it is very good, good, poor, very poor, excellent. So your response is categorical, but it is ranked. Stage of a disease, HIV stage 1, stage 2, cancer stage 1, stage 2, stage 3, depression score. All these are rank variables. Then your continuous variables are quantitative variables. Yeah, we've done this. So how do you summarize your categorical variables? Please, I hope you guys have your writing materials there. Write this thing that I want to say down. It's important. There are 3 levels of analysis that we do in research. There are 3 levels of analysis. Number 1 is the descriptive analysis, or what we call the descriptive statistics. That's number 1. Number 2 is your bivariate analysis, or what we call your test of hypothesis. That's number 2. That's the second level. Number 3 is your multivariate analysis, what we call the prediction modeling, your multivariate analysis. At the stage 1, which is the descriptive analysis, you are just dealing with one variable. So that's where this summary comes in. You are just dealing with one variable. So you want to know what is the mean age, what is the mean height, what is the mean BMI, what is the sex distribution. That is just descriptive analysis. So when you are analyzing your work and you are presenting your results, we expect you to follow that pattern. Your first table should be table 1, descriptive analysis of maybe your social demographic variable, maybe whatever, but it should flow like that. It's wrong to bring, if you did prediction, to go and put it first. No. Your descriptive analysis should come first. Your bivariate analysis, where you did chi-square, t-test, ANOVA, should come in the middle. And then if you did any modeling, it should come last. So how do you do descriptive analysis for a categorical variable? You say that you analyze it in percentage, proportions, and frequency. So for a categorical variable like gender, occupation, tribe, what is your knowledge about HIV, all these categorical variables. How do we analyze them? We say percentage, proportion, and frequency. You can't say mean, you can't say standard deviation, no, because that variable does not contain number. You see how I said query mode. Now, ordinal variables are summarized as median or interquartile range. Ordinal variables are sometimes can appear as both quantitative and qualitative. Sorry, let me admit some students. Okay. So ordinal variables can be, let me give you a popular example, parity. Sometimes we say percentage parity, sometimes we say mean parity. That is an ordinal variable. Now, for quantitative variables, or what we call continuous variables, please, whenever you are dealing with a variable that has numbers, you need to check, you need to do what we call exploratory analysis first. You need to explore that variable and check if it is normally distributed. You are going to see how we do that in STATA. Let me take, for example, I give you age of participants. You are first of all going to check if that age range, if that age is normally distributed.
It's okay. Yes, see.
Can
And
you
I'm
hear
in
me?
this job. Finish. Man, coming. From benzene coming. Okay? ماشي انا بقول لك انا فيسبوك انا موجود فيسبوك yeah. No Facebook here. Call Facebook.
Is
Yeah.
that a question? Hello, please mute your mic. Who is that? Chukuma, please mute your mic. Thank you. All right, so whenever you are working with a quantitative variable, you need to know, is it normally distributed or not? If it is normally distributed, you summarize it, your descriptive analysis will be done as mean and standard deviation. But if it's not normally distributed, please, you don't throw it away. You'll present it as median and interquartile range. I'll show us how to get mean and this. I'll show us how to get mean and this. How do you check whether, in short, what is normal distribution? Does anyone have an idea? What does it mean for a variable, let's say a quantitative variable, let's say age, let's say BMI, what does it mean to be normally distributed? Does anybody have an idea? You can unmute and speak.
Let me try. If you
Try.
say a BMI, we talk about
Yes.
the underweight, overweight, and
Yes.
then obese, and
Okay.
a very
Obesity classes. Yes. Obesity class 1, obesity class 2.
yeah, that's what I'm looking at it. I don't know. That's my honest submission.
Oh, that's not okay. Well, you tried, but that's not entirely correct. Any other
Okay.
try? Thank you for
Okay, so
trying.
I know normal distribution, I feel they usually show something like that Gaussian curve where the more of the numbers are towards the middle so that there will be that peak or height at the middle. Then towards the end, we have the those ones that are, they are like outliers towards the edges.
That's the right word. I know you are looking for that word. Well done. Vitam, well done. Yeah, Kerry, your hand is up.
At 0 point.
I wanted to know if normal distribution also has to deal with being representative of the population that you're studying. So if it is that your sample accurately represents different proportions of your population of interest, then your data will be normally distributed.
Okay. So how do we check if a variable is normally distributed? Yeah, I can hear you. Go ahead.
No, I just wanted to know if that's it also.
All right. You tried. Thank you, Kerry. Thank you. Who else? All right. So now let me give us an example. Whenever you are dealing with a quantitative data, a quantitative variable, please, it's good to see the closeness, how close those numbers are to each other. For example, I have I have 11 persons in this class. If I ask us our age, If I ask us, for example, give me the data, give me your age, type it in the chat box. You can see some persons will be some persons can be 50, some persons can be 25, some persons can be 35, some persons can be maybe, I don't think there is somebody that is 70 in this class. I don't think. I don't know. But the closeness of those data points to each other is all we actually, that thing is all we want to check. The distribution means that there are no outlier points. There are no extreme points, whether on the right or on the left. For example, outliers are data points that fall way above the normal distribution. If you have a BMI of 18.5, 23, 25, and you see a patient with a BMI of 40, and you check, and that data point is correct. And you have 3 patients, maybe you have a data set that contains 50 people, and you have 5 patients with BMIs of 40, 41, 39, those will be outliers. Those 5 data points will make your variable not to be normally distributed because they are far from the distribution, from the sequence, or from the closeness of how close those data points are. I don't know if you guys got me. So it is usually an issue for us when we analyze quantitative variables. We want to check, is this variable normally distributed? Does it follow a normal distribution? So if you plot it on a scatter, on a histogram, or using your Gaussian curve, you will see how the distribution is. The center is usually the mean. The left and right is usually the confidence interval. I'm going to show us when we start doing practicals. So whenever you notice that your variable is normally distributed, please, and you want to do your descriptive analysis, you say mean and standard deviation. You can go ahead and use this mean and standard deviation. Remember that mean and median are measures of central tendency, while standard deviation and interquartile range are measures of spread, or what we call location. Mean goes with standard deviation or standard error of mean, while median goes with interquartile range. So that is it. The interquartile range is usually the 25th percentile to the 75th percentile, while the normal range is your minimum to your maximum. So now, when you analyze your data in STATA, this is what you, okay. So when you analyze your data and you are writing up your results for your descriptive table, this is what we expect to see. Look at sex. Sex is a categorical variable. We say categorical variables are presented in frequency and percentage. This is frequency, this is percentage. So males are 126, giving us a percentage of 61%. Females are 79, 39%. So because sex is a categorical variable, we said categorical variables are summarized in frequencies and percentage. age is a quantitative variable. So you can't say frequency, percentage, you say mean and standard deviation. Mean and standard deviation, mean and standard deviation. See how it is written. Because age is normally distributed. If not, you have median here and interquartile range. Look at ulceration. How many patients have ulcer? You see that 90% had ulcer, which is 44%. So this variable is categorical. That seems percentage and frequency. This thickness too is quantitative. So that's why you're saying mean and standard deviation. So when you read journals, when you read articles, you go just, if you refer to the first tables, this is what you always see. They will always juggle the descriptive analysis together. So some of them you see mean, some of them you see median, some of them you see frequency and percentage, right? So I've already explained this. The first level of analysis that we do is descriptive. The second level is inferential or bivariate. So at the bivariate level, we are trying to compare, trying to determine association, you are trying to determine cause-effect relationships. Please, I'm going to get, when we get to correlation analysis, I'm going to tell us difference between relationship and cause and effect. They are not the same thing. That two things are related does not mean they have a cause and effect relationship on each other. Does not mean that one is causing one. if you establish that there is an association between BMI and cholesterol increase, it does not mean that it is cholesterol increase or BMI increase that is causing an increase in cholesterol. So we're going to still look at that. Then we are going to look at parametric and non-parametric tests for our bivariates. What is the difference? We're going to look at correlation analysis and then the kappa test for test of agreement. And then this is the third level of analysis, our regression. Remember, for every time you set out to do a study, you want to test some hypotheses. Hypotheses can be derived from literatures, can be derived from other studies, derived from your experience in that field. So if I notice that patients with cholesterol, patients with diabetes are usually having an increase in cholesterol with age or with weight, I can write it as an hypothesis that there is a statistically significant increase in cholesterol with age. That is my alternate hypothesis. I can also have the null hypothesis that disagrees and says there is no association between birth weight and gestational diabetes. So the null hypothesis we always say there is no, while the alternate hypothesis we say there is. So we always do a two-tailed hypothesis test. So remember the confidence interval and the p-value, the relationship between confidence interval and p-value. You always hear p-value, p-value, p-value. What does p-value mean? What does p-value mean? I was asked this question when I was applying for my PhD, just basic research question. And some people couldn't even answer it properly. So who can try? If you're hearing p-value, 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 confidence interval, what does it mean? Just try.
P-value is the level of the marginal significance within a statistical hypothesis. I'm saying the p-value is the level of marginal significance within a statistical hypothesis. It's representing the probability of occurrence of a given event.
Okay. That's correct. That's correct. Any other person? Edema, you want to try?
I think he said what I wanted to say. Okay. But I can also add by saying if you have a probability level of 5%, you're nearly saying that the chance of having such a result or a particular result from the same, that is, if you take a sample from a particular population, you have a 5% chance of having the same result if you repeat the experiment within the same population. I don't know if I've mixed it up somewhere.
you did your best. So p-value actually is a function of confidence interval. So we usually have 3 confidence intervals. Many times that we do analysis, 90%, 95, or 99. At 90% confidence interval, the remaining 10% is your level of error. That's the margin you are giving to error. You understand what I'm saying? So another name for p-value, some people call it level of significance, some people call it error margin. So if your confidence interval is at 90%, means that the level of error you are allowing is 10%, which is very large. I wouldn't approve a study that has p-value of 10%. It's too much. So if your confidence interval is 95, the error you're allowing is 5%. That's your p-value. That's your error margin. 5% is 0.05. That's why we say if it's greater than 5%, reject the alternate hypothesis. If it's less than 5%, accept the null hypothesis. Sorry, accept the alternate hypothesis. For 99%, you have 1% chance to error. So some of the WHO clinical trials, sometimes will set the level of error when analyzing the data at 99%. Okay? So if it means that if this study is randomly repeated within the same sample size, parameter of interest, whether mean, whether risk ratio, whether odds ratio, will fall within the confidence level of this, and this out of 100 occasions. So for every time you do this, you repeat that, you do repeat that sampling, 90 or 95% or 99% times, you will get the same values. Because remember, you are sampling from a sample, not the whole population. So someone wants to study diabetic patients in Nigeria, for example. Of course, you can't study all the diabetic patients in Nigeria. It's not possible. Or you want to study in a health facility. We can't mobilize all of them. So you take a sample, maybe 100, 200 that are coming to clinic. So you want to now make inference based on to the whole population, based on that sample. That is why we need to have a level of confidence interval that we can accept, a level of error we can accept before you can make that inference. So that is where p-value was derived from. Okay, so this is it. 0 points can either be 0.01, 0.001, or 0.05. All statistical tests have their peculiar hypothesis. So we usually say if it is less than 0.05, you do what? You reject the null. The reason why you are rejecting the null is that the null is saying there is no association. You reject the null and accept the alternate. But if it is greater than 0.05, except you want to commit a type 1, type 2 error. This is the type 1 error that you commit when you are meant to accept, firstly, as reject the null hypothesis and you accept it. So these things are just theoretical stuff. They don't really apply so much in the practical data analysis. Okay, please, I need to tell us something. When conducting your analysis, this is conducting, and you want to make conclusions from the samples to the general population.
Hello, sir.
Yes.
Hello, sir. On this margin of error,
yes.
If it's greater than 0.05, that is we will reject.
This slide, right?
Or if greater than 0.05, we reject. Then if it's less than 0.05, we accept. I don't know whether it's what we're saying.
You didn't understand it.
Yes,
Should
sir.
I explain it again? Okay.
Yes,
I
sir.
said,
please, sir.
For every time you do an analysis, bivariate analysis, regression modeling, and you got p-values, your two-tailed p-value, remember it's two-tailed p-value that we're using, because we are looking at the two sides of the curve. I'm going to show us when we do the histogram by tomorrow. I'm going to interpret the histogram for us so that you can see the histogram beyond just being a curve. Now, when you look at your p-value and it is less than 0.05, it means that the null hypothesis is wrong. So you reject it. Remember, the null hypothesis is saying there is no association, there is no significance. But there is a significance because the p-value is less than 0.05. So you really have to reject it. And you accept the alternate. Do you now understand? There is strong evidence against the null hypothesis. Yes, that's what it means. Okay. But if it is 0.05 and above, there is strong evidence for null hypothesis. So
we accept the null hypothesis.
So if you don't do this, you either commit a type 1 or type 2 error. Now, for those of us that are in epidemiology and public health, remember that when I teach my students sample size calculation, especially for comparative studies, there is a Z beta that we call the type 2 error. That we always call the power of the study. That's always stated at 80%. The complement of beta 1 minus 0.8, which is 20%. It's usually that value of 0.84. So this is outside this lecture. But if peradventure you are doing a a comparative study tomorrow and you want to calculate your sample size, there is this thing what we call the type 2 error, the beta error. So that you don't commit it. You bring in the type 1 error and the type 2 error in your sample size calculation, the Z alpha divided by 2, and then the Z plus your Z beta, all raised to power 2. Your Z beta is a type 2 error, whether you want to account for. It's also regarded as a power of the study. Okay, so I was saying something. There is what we call confounding variables. This is what I wanted to explain. Confounding variables. Do we have an idea of what confounding variables are? When we say a variable is a confounding variable, what does it mean? Should I go ahead and explain?
It's something
Yes,
that
sir.
could have, maybe something that could have made the conclusion to be biased, something else that is affecting the outcome, but was not
God
our
bless
primary
you.
interest.
You use the right words. You use the right words. Something, well, a variable, not something now, we are dealing with variable. A variable that can cause the outcome on its own. Let me give us a practical example. I believe that many of us here are researchers. If, for example, I say that smoking leads to lung cancer, is that correct? Is that correct? Smoking has can lead to.
It
Okay.
can lead to.
Okay, it can. Or he has an association with lung cancer.
Yes.
Right? Okay. So studies are proving that over time. We've done longitudinal studies and followed people up and see. Now, so we collected data, smoking status, lung cancer, followed the patients up, we collected and saw that. Now, is it only smoking that can cause lung cancer in this patient? Are there other things you feel that can cause lung cancer apart from smoking that we didn't account for in that statement?
Yes.
Example.
If one is living in a place that is a smoky area, maybe hazardous area, that either high dusty area,
just say environment.
Okay.
Simple,
dusty environment or smoky environment.
Very good. So environment is one. What else? What about diet? What about alcohol intake? What about other risk factors?
Maybe genetics. Maybe if the person has a
occupation.
Exactly.
Occupational hazard. Like coal mining.
Too. Yeah, the genetic factor, that's the trigger. So many diseases now. In short, when I was designing my study, because I cannot look at a whole lot of, there are other forms of our consortium, that's people that are looking at the genetic aspect of cancer. So those other variables that you may not have accounted for are what we call confounding variables. They have the ability to cause the outcome on their own. So when you are designing a study, when you plan to write your data analysis plan, please, all of those variables that could be confounded, collect data on them at your study design stage, so that when you come to your analysis, you can do multiple regression analysis to take care of them. I'm going to show us how to take care of confounders when we get to modeling. The reason is that you may spend so much money in doing a study, and when you bring out the result will not be valid. You cannot generalize that. Your recommendations and whatever output and whatever result you are postulating cannot be accepted, because the validity of your study is poor. There are things that reduce validity of study in epidemiology. There is the selection bias. There is this confounding bias. So you must account for this. This is important. But it is best to account for it at the study, not when you are done with study design. You have gotten approval, you started collecting data. And they now want to analyze, and so many people come to me like that. I would say, and I'll be asking them, this statement that you are putting, have you looked at other risk factors, other co-founders? So why didn't you? That's why I said involve somebody that is in your field, that's the biostatistician, so that he can advise you properly. Look at this thing, look at other things, look at this. Have you collected data on this? All right. So when we reach to multivariate analysis, we'll look at which one is outcome, which one is dependent variable. Okay, so look at what I was explaining. This is smoking, this is lung cancer. Smoking is our explanatory variable. Lung cancer is our outcome. So, but some other things like environment, occupation, genetics, genetic makeup of the person are now interplaying between this and this. They can cause the outcome, and they are also related to explanatory variable. They shouldn't be in the causal pathway. So you see, smoking and cancer, age, gender, environment. So if you just come and collect data on this and this, and you want to tell us that it's just smoking that caused lung cancer in this patient, no. The validity of your study will be very poor when you have not accounted for this. All right? So we are all researchers. So this one should be done at the level of the study design. Now, there are what we call parametric tests and non-parametric tests. We are getting to the meat of our training. Parametric tests and non-parametric tests. Whenever you are dealing with a quantitative variable and you subject it to test of normal distribution, and it follows a normal distribution, you can go ahead and use a parametric test. So a parametric test is a test that follows normal distribution of your data, follows the assumption that your data is normally distributed. These are the three assumptions of parametric tests, but the most important is this one. Of course, many times, all other conditions are met. Usually this one that is many times not met. So it's expected that your sample data is more than 30. Expected that you use random sampling, probabilistic sampling. Please, if your study involves sampling, do your best to use probability sampling. Except your study design involves that you may use non-probabilistic like combinance, snowball, judgmentals, quota sampling. It's okay. Okay. So when parametric assumptions are violated, especially this, please, you don't throw away the data, you go for non-parametric tests. So every bivariate analysis that we do has a non-parametric test. Every test has a non-parametric equivalence. All right? So this is a table that I made to list out the parametric tests that we do, when you use them, and their examples. Are you guys following me?
Yes, yes.
All right. So for chi-square, when do you use chi-square? What example? So what type of variable do you use chi-square on? When you have two categorical variables, you want to check for association between the two categorical variables, you use chi-square. C, association between gender and smoking status. So chi-square is also called test of proportion. So whenever you have two categorical variables, use chi-square. Now, another test that is similar to chi-square, but is applied for smaller cells, 2 by 2, 3 by 3, 3 by 2 contingency tables, or cells that have expected frequency less than 5. We have 25%. So I will explain this when we get to this analysis. Hopefully on Saturday next week. We are going to see the difference between chi-square and Fisher cell. When do you use this? When do you use this? Association between some gender and smoking status, but on a small sample size. Because it was observed that chi-square is a test that is based on approximation statistics. So it does not do well for small size tables. For Fisher says that test can do well for, they serve the same function, but it's for small size tables because it is based on exact statistics. Then there is what we call student t-test or independent t-test. It is used when you have a continuous variable.
Sorry. Hello, sir.
Yes.
The Fisher says that test.
Yes.
Please, I need a little bit explanation on that Fisher says that test, sir.
Okay.
The categorical versus categorical test. Let me just have a clarification. Let me clarification on that, sir.
I didn't get, what do you want me to explain? Should I re-explain it again?
You're talking about the teacher's exact test.
Yes, yes.
The explanation, I did not understand properly the explanation.
Okay,
on
okay.
that.
I was saying, just listen, that it is a variance of chi-square. But there are sometimes you have small size tables that have expected frequency or expected. I will show you, you may not understand it well because you have not done the practical. So when we get to the practical, don't miss any class. Well, I'm going to show you the practical application of a cell having expected frequency less than 5. So it means that that cell is small. If you have 25 up to 25% of cells that are small in a table, in a cross tabulation table, in a contingency table, please use report Fisher's exact p-value, not chi-square. That's just all we are saying. There are tests of association, there are categorical versus categorical, but you need to look at, whenever you do a chi-square, you need to look at the expected frequencies of each of the observations and see if there are plenty of them that are less than 5. It means that they are small. Do you understand it now?
Okay, sir.
Let's go. He wants to get 25%. So if the cell is 6, 25% of 6 is 2. If the total cell is 10, 25% of 10 is 4. So you need at least 4 cells that have expected frequency less than 5. I'm going to show you, don't worry. You understand it more on the practical. We are just doing the theory. So for t-test, you have continuous versus group. Remember that t-test only analyzes 2 groups. Emphasis on this, 2 groups. If you have more than 2, you go for ANOVA, not t-test. Somebody wants to look at glucose level among obese and non-obese women. This is a group of women. This is another group of women. So you use an independent sample t-test or a student t-test because it's just 2 groups. Now, one-way ANOVA, one-way analysis of variance. We use it when we have a continuous versus group variable that has more than 2 categories. Example, what is the difference in mean age between different stages of HIV? So we have stage 1 to stage 4. See, patients that are in stage 1, what is their mean age? Patients that are in stage 2, what is their mean age? Patients that are in stage 3, what is their mean? Patients that are in stage 4, is there any significant difference between them? That is ANOVA for you. Or the stages are more than 2. Okay? Then you have the Pearson correlation coefficient. The same way we use chi-square for association or relationship, that is the same way we use correlation coefficient for relationship. But when we have continuous versus continuous variable, example, age versus height, weight versus body temperature, body surface area versus BMI. So because the 2 variables are quantitative, we want to look for what is the association between this variable and this variable. Does it mean that as age increases, cholesterol level in diabetic patient increases too? We are going to do a correlation analysis. So you see the example, correlation between CD4 count and back cell volume. Please, before you do a correlation analysis, note that 2 variables involved must be quantitative. If not, you stick with chi-square. And there is what we call the paired t-test. There are times we want to do a before and after analysis. Let's take, for example, you gather some patients, you give them drug, as you measure their weight at baseline, and then you give them a drug, or you expose them to a particular therapy, or exercise, or vaccine, or whatever is the intervention that you give, and you call the same patient and measure their weight again to see if the drug that you gave them had an effect on their weight, whether an increase or a decrease. So if you want to see the difference between the pre and post, that's before and after, you do a what? A paired t-test. We call it, another name for it is dependent t-test. That's another name. Do a paired t-test. But the 2 variables involved must be quantitative. Weight after, weight before, weight after. Blood pressure before, blood pressure after. So see the example. In case where you have a before and after analysis, but the variable is qualitative, that's categorical. You are going to do what? An McNemar test. Please. Categorical before, categorical after. You want to see what is the proportion of HIV patients before introduction of a vaccine and after introduction of the vaccine. HIV cannot be estimated as quantitative. It's either positive or negative. There is no, except you want to see the CD4 count. You cannot estimate that. So such a variable that has qualitative before and after is what? McNemar test. I've done this test several times for specialized type of studies. Then lastly, there is one we call the kappa test. We call it the test of agreement. Let me take, for example, someone wants to see if there is two methods of diagnosis. Okay? Two methods of diagnosis of a disease. You want to see if there is an agreement between them, or if there is a difference between them, what we call concordance. You use the kappa test. So the kappa test gives you a kappa score. Once it's greater than 0.5, you say yes, there is a good kappa score should be between 0.8. A good kappa score should be between 0.8 to 1. So you see some studies like that. See test of agreement between use of HPV testing and pap smear among the same set of women. So do the kappa test. So the same way we have all these parametric tests, that's the same way we have non-parametric tests, remember. So for each time your data does not meet up the assumption for any of these tests, please go and look for the non-parametric equivalent of that test and do. Now look at the non-parametric test that we have. Van Whitney, Wallis, Recoxin. These two are either parametric or non-parametric. They're not, you can use it anywhere. But you see, Van Whitney test, Wallis, Recoxin, Spearman's rank correlation. It's just the same thing that it does, but the difference is that because the variable is not normally distributed, go for non-parametric analysis. Or the variable is ordinal, the quantitative variable is ordinal. Remember that normally at the face level, ordinal variables are assumed not to be normally distributed because of that they are ranking they usually have. There was a study that we did. We looked at pain score among secondary school students before and after there is this drug that was tested. So I used, instead of using the paired sample test, I used the Recoxin sign rank test because we are looking at pain score, and pain is rated a score. So it was assumed that because it's an ordinal variable, it's not normal distributed. Okay, that's why I use non-parametric analysis for that study. So finally, wrapping up, these are so go through these slides. I've sent everyone this. I was that gracious. Okay, the people that didn't register for this course are not meant to get these materials, but I said, no problem. Maybe people have the reasons why they have not registered yet. So you have this material with you, can go over it. And then when we come to class, when we do correlation, I will explain what we call correlation coefficients. What does it mean for a positive correlation, negative correlation, strong correlation, weak correlation? So we'll look at all this in our subsequent classes. So thank you for listening. Just have 4 minutes more. Any questions?
Thank you so much. Thank you.
I believe that this brought a clarity to you. So from now onwards, after this training, you should know the tests to use for your analysis, how to handle it, STATA, how to apply the right analysis for your results, how to design your objectives. As you're writing your objective, you already know the analysis you're going to use. That is what makes you an excellent researcher. People like if you give me your study, in short, once I read your objective, I already know I already know the variable you are collecting, how to analyze it, what you do, I've already seen your results. So that is what the knowledge of this will make. Once I hear you want to predict, you want to see the diagnostic accuracy of a test over another, you want to do this one, you want to check the efficacy of a drug, I already know the analysis you are going to use and the graphs you are going to plot.
Hello, sir.
Yes.
Sir, from the discussion, let me just thank you so much for an insightful lecture. And from the discussion, let me understand this parametric is scores greater than 30, where non-parametrics are scores less than 30.
Yes, there are some times that your data is very small. A data that is less than 30 is regarded as small data generally in statistics. It's regarded as a sample. That is why whenever someone calculates sample size and brings to me, I will tell you to please do whatever you want to do, even if you're having 3 groups of patients. Let the group be more than at least 32 or at bad as about 30, so that you don't run into that error of using non-parametric analysis. Because parametric tests have more statistical power. When we start doing it, you start seeing the difference. Parametric tests have more statistical power than non-parametric analysis. So sometimes assessors and reviewers would like you to use parametric analysis, but your data must meet the conditions. Normal distribution, greater than 30 or 30 and above, and then random sampling or probabilistic sampling.
Okay, sir. In the situation that maybe in a trial, you are doing a trial, conducting a trial, you are comparing 2 or 3, clinical trial, comparing 2 groups, and maybe this trial involve they are continuous variable. You have continuous variable, but for the fact that the number is less than 30, then I will see you going to use it as non-parametric.
You are going to use it. No, yes. After your trial, you get your data. You are going to
because you are looking for efficacy or efficiency.
It's okay. We are going to use median differences. Except I'm going to advise you to have 30 per group, whatever trial you are doing. It is believed you can't. It will be well. I wonder why you shouldn't have up to 30 per group. Don't you want? You remember
because
that
of the resources, of the available resources, and all what you may narrow it less than 10.
You seek for funding now. You seek for funding. Or you seek for collaboration. The research is not done. It's not. You can't do a trial alone now. You have research assistants. You have people, other researchers that will do it with you. Nobody must these days. Nobody even publishes alone. Can't. It's not. Whenever I see a work and a study that just 2 people did, I am not comfortable, because I know that there is a lot, especially when it's a clinical trial. No. You should have a lot of researchers, and you should guys to contribute resources. If there is no grant for it. So that's why many people don't embark on cohort studies a lot. All these cohort studies, clinical trial, they don't embark on it a lot because of the resources involved. Because you need to sample at least more than 30 participants per group. Because before you can establish whatever you want to, the efficacy of whatever you want to measure. That's the statistical principle. Do you understand now?
Yes, sir.
So you seek for funding.
Thank you. Thank you.
Any question? I believe you guys have learned a lot. Yes, before we go.
I did not start on time. I came late. I was thinking that it's 8 o'clock. I was preparing for 8 o'clock.
No. Please, it's 7 to 9, not 8.
Okay.
I don't want us to be finishing by 10. Yes. 7 to 9. Please, before we go, I want us to do a quick introduction of ourselves. I usually do it when we start the lecture, because you can also network here. So just unmute yourself, introduce yourself, tell us possibly what you do, and we'll know you and you know us. So I'll start with myself. Of course, you guys have seen it on my portfolio. I'm a doctoral research fellow. I'm leading a cancer research, and I am a data scientist. I use R, I use Stata, I use SPSS, I use SQL, I use Microsoft Excel to an advanced level. I teach it too. I use Power BI for data visualization, and I use MVivo for qualitative analysis. So I'm a very experienced, let me not say, I'm an early career researcher, though I published more than 30 articles. So still doing my PhD. So Dr. Alfred, you are next.
Okay, I'm Dr. Alfred Chibike Seda. I'm a medical practitioner and also a teacher. I think that's left I can say, sir. Thank you, sir.
All right, welcome. Edema, you are next.
Okay,
Sorry,
Edema.
Sorry if I didn't get your name correct.
You tried. I'm Edema Imalile, and I'm affiliated with University of Calabar.
Okay.
I'm a researcher there, and I'm into NTDs,
very
specifically schistosomiasis and soil-transmitted hemitiasis.
Neglected tropical disease, okay?
Yes,
Chukuma Chibike,
yes.
you are next.
Hello, can you hear me?
We can. Go ahead.
Yes, we can hear you.
Yes. Okay. Good evening, everyone. Good evening, Mr. Chisom. Thank you so much for the this today's presentation and lecture. So I am Dr. Chukuma Chibike, medical practitioner and public health specialist, and currently a PhD student in public health. Thank you.
Welcome. Welcome. One for Helen, you're next.
Hello, did you get me?
Yes, sir, we got you. Well, you're welcome, sir. One for Helen, you are next.
Right,
Ibitam, you are next.
Thank you. Good night.
Please.
Good evening, everyone. My name is Otomja Ibitam.
Ibitam, just hold on. Tomorrow's class, please do well to register and pay for your course. This is not a free training, please. If you can't pay everything, just pay 70% and finish the remaining. Please, tomorrow is going to be for paid participants. Thank you. Go ahead.
Good evening, everyone. My name is Otomja Ibitam. I'm a medical laboratory scientist and a public health specialist, currently doing my PhD in public health in the University of Port Harcourt.
Wow. Welcome. What set are you? Ibitam, what set are you?
2022, 2023.
I see.
2022.
Okay. Rosalind.
Yeah, good evening, everybody. I'm Rosalind Eze. I'm a medical practitioner, and yeah, and it's basically I actually left the scene in terms of active research a while ago to focus on family. So the intention now is to use this course as a springboard to come back into the scene. So that explains why I was a listener almost all through, contributing really little, if at all. But at least I'm fine, I'm back. And it was a very, very insightful lecture, and I'm happy I'm here. And hopefully I intend to register so that I can benefit from this course. So thank you so much, sir.
All right, welcome. Thank you for joining. What's your reaction?
Good evening, all. Thank you so much, Mr. Chisom. My name is Uche Uriaku. I'm a medical practitioner and a public health specialist. Thank you so much. Your lecture today has been quite expository, and I think it's quite an eye-opener. Yeah, we really appreciate it. Thank you.
All right. Wonderful.